Hello, I'm Ken where I'm going to explain Theorem 7 to 10. In Theorem 7, it states that two lines which is perpendicular to the same plane, then they are parallel. And conversely, if one of two parallel lines is perpendicular to the plane, then the other is also. To prove Theorem 7, we must first identify the plane and the lines. I have here a table, and this table stands upright to the floor. So in Theorem 7, first thing we do is to identify the plane and the lines. So the floor here is the plane, and these two legs are the lines. So as you can see, the two lines stands upright to the floor. So it means that the two lines are perpendicular to the same plane, which is the floor. So we can conclude that these lines are parallel to each other, and by that, Theorem 7 is stated. Theorem 8. If a straight line is parallel to the given plane, then it is parallel to the intersection of any plane through it with the given plane. Here, I have here two planes, the wall and the floor. So to prove Theorem 8, we must first identify the intersection of two planes and the line which is parallel to the intersection of two planes. So the intersection of two planes here is this line, which is stated in Theorem 1. So this plane and this plane intersect this common line. So there is a line above the wall, which is that line, and that line is parallel to the section of two planes. So you can see that that line and this line here cannot meet, so they are parallel. Theorem 9. If each of two planes is perpendicular to the same line, then they are parallel. And conversely, if one of two parallel planes is perpendicular to the line, then the other is also. To prove Theorem 9, we must first identify the two planes and the line which the planes are perpendicular to the same line. I have here two planes, the floor and the ceiling. So to prove Theorem 9, we must prove that these planes are parallel. So to prove that, we must have a line which is perpendicular to each of two planes. So this line here is the line which the two planes is perpendicular. So look at it. This floor is perpendicular to this line, and the ceiling is also perpendicular to this line. So the two planes cannot meet, so they are parallel because they are perpendicular to the same line. Theorem 10. If a plane is parallel to the two intersecting lines, it is parallel to the plane of these lines. To prove Theorem 10, we must first determine a plane and the plane parallel to it. So I have here a plane. This is a plane, and it is determined by two intersecting lines. And I have also a plane above, which is the ceiling. So you can see that to prove the theorem 10, we must construct a line. So this is the line. So you can see that this line is perpendicular to this line, to the intersecting lines. And also, this line is also perpendicular to the plane above. So we can conclude that the line above is perpendicular to this line, and also this intersecting line is perpendicular to the line. Then the plane above is parallel to the plane of these two intersecting lines. So the theorem 10 is therefore proved. To prove theorem 11, we must first identify the point not in the plane. So first thing we do is to find the point not in the plane. So there is a point there and there's a plane here, which is the floor. So you can see that the point is not in the plane. Yeah? And for me, a point also determines two intersecting lines and the intersection of a plane and a line, because if we intersect this line and that plane above, then the intersection is a point. And also, if we intersect two lines, the intersection of them is also called point. So we can say that the plane above and the plane here on the floor is parallel, because as you can see, the plane here intersect in this line, and the plane there, which the point is in there, is also have common line. So then they are parallel to each other. Then there is only one plane parallel to that plane.
To prove theorem 12, let first determine a skew line. This line and this line. Then this line and this line intersect to determine a plane. Then to prove theorem 12, this plane and this line are parallel. We must first identify a new plane, this plane. Then this plane meet in this plane meet in this line, and also this plane meet in this line. Then both lines meet on the same plane. So therefore, this line and this line are parallel. To prove theorem 13, let first determine the plane or non-parallel lines. This, if say non-parallel lines, it will say they are skew line or intersecting lines. So this is the line. So this is intersecting lines to determine this plane and this point. So then this plane and this point are parallel. To prove theorem 14, let first determine a plane.
Yes.
This line and this line intersect, then we can know that this is plane, and this line and this line intersect to determine a plane. Then if this plane and this plane perpendicular to this line, therefore they are parallel.
We have two lines cut by three parallel planes, and I need to prove that these lines is the same with this line. If this line is perpendicular to this plane, and also this line is perpendicular to this plane, therefore this line is the same with this line. Since these lines are perpendicular to these planes, which these planes are parallel, therefore this line also is perpendicular to this plane. And since this line is perpendicular to this plane, therefore this line is perpendicular to this plane. And since these lines are the same, therefore this line is the same by this line.
Dihedral angle is when two planes intersect in a common line. So this is the plane here and it's a plane here and intersect in this line, which is the edge. The planes here are called the half planes and this is called edge, and they form a dihedral angle.
To prove theorem 16, let's first determine the two dihedral angles. Two planes and the common edge is this, and these are the dihedral angles. And these two planes and the common edge is this, and they are dihedral angles. And these dihedral angles are equal.
We have a door and a floor. Represents our two planes, which is mutually perpendicular. On this door, we have a point. From this point, we put a line here to their intersection, and I need to prove that this line is perpendicular to this floor. Since the line here is upright from the floor, therefore this line from this point to this floor is perpendicular. This door and this wall are intersect in a common edge, whereas these two planes are perpendicular to the floor. Then I need to prove that this line, which is their common edge, is perpendicular to the floor. And then, since this door is perpendicular to the floor and also the wall perpendicular to the floor, therefore their common edge or the line which is upright to the floor is perpendicular to the floor.